What we're looking at today are these things called special triangles, and they're special because when we take the trig ratio of certain values of these angles, they end up being very nice numbers, easily grasped, and no ugly decimal numbers that go on and on. Although some of them can be converted into ugly decimals, for the most part they behave nicely. So let's start off with just an equilateral triangle here. I'm going to have the side length equal to 2. So I'm just randomly assigning a side length of 2. I could have chosen any number, but I'm going to choose 2. And let me just get rid of this little mark here. I have this 2 here, which I don't need. Great. Okay. What I'm going to do now is divide this triangle in half. So I'm going to draw an altitude or perpendicular from the top angle down to the bottom. Let me just maybe center that a little bit more so that I get something like this. And what that does effectively is that it bisects the angle up here from 60 into 30 degrees. So what I'm going to get here is now a 30-degree angle. And at the bottom, I actually bisect the bottom side into 2 equal values, and because the side length is 2, this is going to be 1. Because it is an altitude, it's going to be 90 degrees. So I'm just going to fill out this triangle as such. I'm going to draw this side here, just tracing over. I'm going to draw this side here, and I'm just tracing over. And of course I have in this angle here, which I'll just draw in again, is 60 degrees. So if I remove this triangle now, let me just take this part here and bring it outside, what I notice now is I have a triangle that is 90, 30, 60, and you're going to hear that often, with a hypotenuse of 2 and a base of 1. Well, what about that third side there? How could I solve for it? Well, let's just use Pythagoras. X squared plus 1 squared is equal to 2 squared. And if I do the math, I get 3. Try that again. Or, because we're only using positive values, I end up with root 3. So what we call this is our 2 root 3 1 triangle, or 1 2 root root 3 triangle, because those are the sides of the corresponding triangle. So how am I going to use this? Well, let me take this triangle now and bring it down here. And it says, well, suppose you were to, superimpose this triangle onto the Cartesian plane. And I can actually do this with this iPad. I'm going to take this triangle, I'm going to tilt it and put it like right over here. Okay, obviously it's not drawn exactly, but close enough, right? What you notice is that, okay, that's cool. I have an angle of 30 degrees, a side of root 3, a side of 1, and a side of 2. Let me just take off this superimposed triangle because I already have it on the plane there. Okay. So here's a nice thing, is that once you have this, keeping in mind that angles are measured from 0. Okay, let me zoom in here. So if this is my horizontal, this is 0 degrees. From here to here, that's 30. So that's 30 degrees. And I can essentially calculate the values of sine, cosine, and tangent of 30 using that right angle triangle. Okay, let's do that. So I'm going to write over here, sine 30, by definition of sine, is opposite over hypotenuse, or 1 over 2. Cosine 30 is equal to root 3 over 2. And tangent of 30 is equal to 1 over root 3. And that's what we mean by, the exact values of sine, cosine, and tan of 30. Okay, and that's why we call it a special triangle, because it fits nicely into our Cartesian plane. Okay, what about for the exact values for 150, 210, and 330? Well, let's go back to our picture here. And what I'm going to do, let me just erase this stuff here, is take this triangle, and I'm just going to simplify it. I'm going to get rid of all these sides here. Okay, maybe just mark this side because we know it's 30 degrees. Okay, well, it says, well, what about 150? 150. What about, what's the other one? 210. 210. And what about 330? Now, these aren't chosen randomly. They're actually chosen with a special purpose in mind. Namely, I'm going to superimpose this triangle using the cast rule in the various quadrants with a related acute angle of 30 degrees. So here's what I mean. I'm going to take this guy, and I can't really reflect it in this app, but I'm going to do this at least. Okay. Now I'm looking at this angle here, right? That's going to be 210. And if I looked at it up here, put it this way, drop it down, this angle here would be 150. And if I went all the way here, again 30 degrees, let me extend that a bit, all the way around, that would be 330 degrees. Okay, so using the measurements, but depending on which quadrant they're in, making them positive or negative accordingly, we can calculate the values of 150, 210, and 330. Here's what I mean. So the hypotenuse is 2 here, 2 here, and 2 here. In the quadrant 4, I'm going to have negative 1. Root 3 is going to be the same because it's positive x axes. Over here, I'm going to have negative 1, and I'm going to have negative root 3 over here, and here I'll have positive 1. Okay? I can basically calculate now the sine, cosine, and tangent of all these angles as well. Okay, well, I can go sine of 150, and by the way, you could have done this just using the cast rule, but I want to show a kind of a visual of what it looks like. Sine of 150 is also 1 over 2. Okay, cosine of 150 is going to be negative root 3 over 2, and tan of 150 is going to be, what do we have there? 1 over negative root 3, but I'm just going to put the negative at the, oh, sorry about that. I'm just going to put the negative at the top and circle this. Let me try that again. Put it up here. And that's the values for sine of 150. And I can continue going. I can do, well, what about for 210? So sine of 210, well, let's just use the cast rule at this point. We know sine is going to be negative in that quadrant, so I'll have negative 1 over 2. Cos of 210 is going to be negative in that quadrant, so I'll have negative root 3 over 2, and tangent of 210 is also going to be negative in that, is going to be positive in that quadrant, so I'll have 1 over root 3. Finally, for sine of 330, cos of 330, and tan of 330, I'll let you finish that, okay? Get the same values, just the sign changing. And that's what we mean by our special triangle of a 90, 30, 60, or 1, 2, root 3 triangle, and how we can use it to find the various trig ratios for those corresponding angles.